So in this question, we're going to be looking at slopes and tangents of curves as it relates to calculus. And so we're told here the curve has an equation y is equal to x cubed minus 4x plus 7. So it's going to be a cubic curve here, and we're asked to find dy dx, the slope of the tangent of the curve at any point along the curve. And so they tell us exactly what they want here, which is dy dx. And to find that, we can use our rule for differentiating polynomials, which hopefully you've learned off by now. But if not, you just basically take down the power in front. So because we have x cubed in our question, it becomes 3 out in front, and then x squared, so reducing it from cubed down to squared, or 3 down to 2. And then our minus 4x just becomes minus 4, because we're reducing the power of x to 0, which is just going to become minus 4 instead. And then for this plus 7, it's just going to go to 0. So we don't actually have to include that. So this is dy dx. And so we picked up some handy marks now just for finding that. And moving on to the second part now, we're asked to hence find the equation of the tangent of the curve that we differentiated above at the point 2 minus 3. So this is going to incorporate some skills from coordinate geometry to find the equation of a line given a point on the line, and also the slope. And so we know that dy dx for our curve is the slope, so that's going to be 3x squared minus 4. And so our first step here is going to be to plug in our x coordinate, which is 2, into this dy dx equation to find out what the slope is. So m, which is going to be the slope of our tangent, is just going to be 8, because we've got 3 times 2 squared minus 4, which is 12 minus 4, which is going to be 8. So that is going to be the first step of this kind of style of question where we're asked to find the equation of the tangent of the curve. And the second step here is going to be to use our formula. Y minus y1 is equal to m times x minus x1. And so this is the formula we use whenever we have a point and a slope and we want the equation of the line. And so we can just plug this all in now to find our equation of our line. So y1 is going to be minus 3, so we're going to have minus 3. That's going to be equal to 8, which is our slope, times x minus 2, which is just going to be x minus 2 straightforwardly. And so we can now simplify our left hand side to y plus 3, so y minus 3 is y plus 3, and then our right hand side is going to become 8x minus 16, because we just are going to simplify our brackets. And then finally, to get the equation, we're going to have to subtract 3 all the way across, and that is going to give us y is equal to 8x minus 19. And so that's in the form y is equal to mx plus c, or alternatively in our other form, which is going to be ax plus by plus c is equal to 0, we have 8x minus y minus 19 is equal to 0. So these are 2 forms for the equation of the line, and therefore we can say we've answered this question now. And so for part 3 here, we're told that g dash phi is equal to 6, and we're given the function g of x is equal to x cubed minus 7x squared plus x minus 12, where x is a real number. And we're asked to use this to find the equation of the tangent to the curve y is equal to gx when x is equal to 5, to give our answer in the form ax plus by plus c is equal to 0. So whenever we're looking to find a tangent to a curve, we need to ask ourselves just a few bits of information. The first bit is, do we have the slope of the line? And in this case we do, because we know that g dash phi is equal to 6. So they basically just hand us the slope, or the rate of change at that point. And again, we're dealing with the point x is equal to 5 here, so they give us that in the question. And all that's left for us to do is find the equation of the tangent using the slope and also using a point. And so you'll notice we have the x coordinate, which is 5. And so our first step here is going to be to find the y coordinate. And so our y coordinate, which is going to be g of 5 is equal to 5 cubed minus 7 times 5 squared plus 5 minus 12, or in other words, we're just plugging 5 straight into this g of x formula to find our y coordinate. And so we're just going to simplify this now, and we're going to get that our y is equal to minus 57. So this is going to be our y coordinate, and so our point is going to be the point 5 comma minus 57. So this is the point which is the kind of tangential point to the curve, so it's going to be the point at which our line that we're going to be finding crosses our original curve. And so the final step of the question is just going to be to find the actual equation of the curve, so we can call that step 1, find y using x. Step 2 is going to be to use our slope and our point in our formula y minus y1 is equal to m times x minus x1. So that is going to be our kind of final step to finish this off. So y stays the same, it's just a general y. Y1 is our actual y coordinate on our point, which is going to be minus 57. So we're going to be subtracting minus 57 on the left hand side, and then m is going to be this number 6, which is g dash phi, which we're given in the question, and that is going to be multiplied by x minus x1, or x minus 5, because we're told in the question that we're going to be dealing with the x coordinate 5. And so now all that's left to do is to simplify this and to rearrange it. So we're going to have y plus 57 is equal to 6x minus 30, And then our next step is just going to be to get everything on one side, including y's and x's, and then just have 0 on the right hand side. Since we are told to give our answer in the form ax plus by plus c is equal to 0, so this is kind of just an alternative form we can give the line in, as opposed to y is equal to mx plus c, which is usually what we would opt for. But yeah, in this case, we're just going to be getting everything all onto one side. And so in its final form, the equation of our line is going to be 6x minus y minus 87 is equal to 0. And that's in the correct form now, so that is going to be it for this question.